Biowave is a very simple to use system, but the way that the electrodes are placed is completely different than how you've been taught with conventional TENS or interferential or other types of electrical stimulation. So it's very important to understand the rationale for our electrode placement. So I'm going to start by explaining our signal technology, and that will provide the rationale. In order to affect a nerve fiber or pain fiber inside the body, you have to encompass that nerve with a low frequency electrical field. We define low frequency 1 hertz to about 180 hertz in frequency. The problem is skin has very high impedance and high capacitance, and low frequency signals, regardless of the shape of the waveform, cannot pass through skin. They only travel across the surface of the skin, and that's a fundamental problem with TENS. High frequency signals, we define that as greater than 1,000 hertz in frequency, particularly if they're a sinusoidal waveform, can pass through skin into deep tissue. But individually, high frequency signals have no effect on nociceptive pain fibers. What we discovered, we proved in a rabbit model at Cornell at New York Hospital. And what we discovered, and we had 5 probes inside the body of the rabbit, is when you add together 2 high frequency signals, both sinusoidal waveforms, pass through the skin into deep tissue, we discovered when the charge at the surface of the nociceptive pain fibers, the plus charge, or the polarity of those nerves or any tissue inside the body, causes these 2 high frequency signals to multiply together. And the multiplication of these 2 sine waves causes a new spectrum of signals to form in approximately a 3-inch diameter hemisphere beneath a 2-inch diameter electrode. The active electrical field that forms in this hemisphere is comprised of 3 high-frequency signals and many low-frequency signals. So what we discovered is a way to get the body to produce low frequency internally, right at the surface of the nociceptive pain fibers. Then we did our first human study at Cornell at New York Hospital, and we discovered there was an optimal set of high-frequency signals to get energy to pass through skin, and there was an optimal low-frequency signal that formed inside the body that prevented the sodium-potassium ion exchange across the membrane of the C fiber. So it prevents, the electrical field prevents action potential propagation along the C fiber. So it turns out we looked at different high-frequency signals going through the skin and different low-frequency signals that formed inside the body. And it turns out if you could get the body to produce a specific low-frequency electrical field right at the surface of the nociceptive pain fibers, it caused the greatest reduction in pain scores, in visual analog scale pain scores from before to after treatment. So it allowed us to design a very simple to use device. There's no programming. The only thing that's controlled is the intensity, and the patient controls it by pressing the plus button or the minus button on the face of the device. So this is very simple to use. It's power button and plus button.